Hello everyone, hope all you are doing well. Today we'll discuss about allotropes of carbon and hydrocarbons. In my earlier lecture of the chapter carbon and its compound, I have explained their bonding in carbon, that is covalent bond. So today we'll discuss about allotropes of carbon. Now, what is allotropes? Yes, allotrope is the property of those elements who can be exist in different form, for which their physical properties will different and chemical properties will be same. Example of this allotropes of carbon are diamond, graphite and Buckminster fluorines. And all these three, made up of carbon atoms, but their arrangement of carbon is different. Due to their different arrangement of carbon, they show different physical properties. But chemically they are same. They are made up of carbons. That is why they show the similar chemical properties. So in case of diamond, what happens? One, I mean carbon is bonded with four other carbon atoms. What happens? One carbon atom is bonded with four other carbon atoms, and in this way they give a rigid 3D structures, for which diamond is very much hard in nature, and that is why it is called as hardest natural substances. Okay, but in case of graphite, the arrangement of carbon is different. You see, in case of graphite, what happens? You know that carbon are arranged in a ring like, in a hexagonal rings. Carbon are arranged in a hexagonal rings. Okay, carbon are arranged in a hexagonal rings. Here, three hexagonal rings they will lie. One hexagonal rings they will lie over one another in the same plane, and they will be bind with a van der Waal force. This the dot dot. These are the van der Waal force. It is a weak force for which the graphite is slippery and soft. And you know that through graphite, electricity conduction is possible. Why? Yes, I have already made another video on graphite, that why it conducts electricity. So you search in my YouTube channel, that Cold Spring Academy, why graphite conducts electricity, you will get it there. Have you understood? Okay. So this is the arrangement of what? That is carbon. So here, see, in every corner of this hexagon, it made up of what? Carbon. Okay. So another allotropes of carbon is what? Buckminster fluorines. Okay. And it is made up of 60 carbon, and the carbon are arranged in a what? In a shape of football like. Okay, inside there is a hollow case. Are you getting my point? What I'm saying? That means allotropes means what? It is the property of the elements who can be exist in different form. In diamond, you see the carbon they arranged. In one carbon they are arranged four carbon atoms, and they give a rigid 3D structures. In graphite, the carbon is arranged in a hexagonal rings, and one hexagonal rings is arranged over one hexagonal rings. But in case of fluorines, what happens? 60 number of carbon they arranged in the shape of like football. Okay, chemically all these three made up of carbon, but difference is that their arrangement is different, for which they show different physical properties, and their chemical properties is same. Okay. Okay, now we'll discuss about versatile nature of carbon. There are actually two characteristics which makes the carbon versatile. Number one is catenations, number two is tetravalency. What is catenation? I mean, carbon atoms have the ability to bond with the other carbon atom, and they can form a long chain, and they can give us a what large what molecules, I mean big molecules, and this property of carbon is known as catenations. Okay, so does carbon only shows the catenation? No, there are other elements also they show the catenations, but highest catenation can be shown by the carbon. You getting my point? So in your NCERT textbook, it is said that silicon, what? Silicon hardly silicon atoms they can arrange what? In the form of 8 atoms, and they can combine with hydrogen, and this is called octasilane. OCTASILANE, octasilane. Octasilane. Okay, where silicon can be bonded with other silicon atom up to 7 to 8. Here you see silicon number is what? 8. If they will add more number of silicon, then they will lose their stability. They will decompose it. But carbon is the only element who can what? I mean join with carbon atom like many, like 20, 30, 40 like that. It can join many carbon atoms. That is why they said that. I mean highest tendency of catenation, it can only be shown by your carbon. Okay, so you just note it down. What the name of this compound? Octasilane. Here silicon, 8 silicon, it is joined in this way. Si, 1, 2, 3, 4, 5, 6, 7, 8. Hardly 8 silicon atom they can join. 7 to 8. If they join more silicon atom, their stability will be lost. And here there will be how many hydrogen? 18 hydrogen. It will be like that. It will be like that everywhere. There will be hydrogen, and this is the structure of octasilane. Okay, let me rub it. Okay, next versatile nature of carbon is tetravalency. What is tetravalency? Yes, since the carbon valence is 4, they can form 4 covalent bond, and that property of carbon is known as tetravalency. Their covalence is what? 4. Okay, and whenever carbon join with the other atoms or other element, that bond is very much stronger. Why? Because carbon is small in size. Whenever a atom will be smaller in size, suppose this is the carbon atoms, in middle, you know, in the middle what is there? Proton and neutron is there of an atom or not? And there will be shell, there will be electron. Okay, let me consider this the outer shell. Let just this the outer shell of the carbon. The distance, if the size of the carbon is smaller, then distance from the nucleus to the electron will be what? Shorter. When distance is shorter, then more electrostatic force will be there. Strong electrostatic force will be there. Okay, so due to small size of the carbon, okay, they can form a strong bond with the other atoms. Okay, so now we'll discuss about, that is what? Hydrocarbon. What we'll discuss? Hydrocarbon. Hydrocarbon. Now what is hydrocarbon? Actually the organic compounds or the compounds which is made up of only by carbon and hydrogen atom, that is known as hydrocarbon. Okay, hydrocarbon are of two types. One is saturated hydrocarbon, SATURA, saturated hydrocarbon. Another is unsaturated hydrocarbon. Actually, saturated hydrocarbon are those hydrocarbon, okay, in where at least there is what? Single covalent bond. I mean, in between the two carbon, there will be what? Single covalent bond. And the example of this saturated hydrocarbon will be alkane, which is made up of only by single covalent bond. And unsaturated hydrocarbon means what? I mean, the hydrocarbon or the compounds, the carbon compounds, where there will be double covalent bond or triple covalent bond, at least in one position in a chain. Okay, so unsaturated hydrocarbon example is alkene, and an alkene is formed by double covalent bond. Okay, and another one is alkyne, which is formed by triple covalent bond. That means in case of saturated hydrocarbons, okay, there will be a single covalent bond. I mean, the hydrocarbon which is formed by double covalent bond, it is called unsaturated. Okay, or the covalent bond which is by triple covalent bond, which is known as what? Unsaturated hydrocarbons. So in case of alkane, there will be single covalent bond. In case of alkene, there will be double covalent bond. In case of alkyne, there will be triple covalent bond. Okay, now you see the general formula of alkane is CnH twice N plus 2, and general formula of alkene is CnH twice N, and general formula of alkyne is CnH twice N minus 2, and where N represents the number of carbon atom in a carbon chain. Okay, now first let me discuss about the alkane. After that I will discuss alkene and alkyne. Now let me rub this. Okay, now what we'll discuss? Alkane. Okay, general formula CnH twice N plus 2. It is a what? Saturated hydrocarbon. Okay, which is formed by single covalent bond. You see, in a carbon chain, if there is one carbon, that we called it as a meth. If there is what? Double carbon in a carbon chain, that we may write eth. If there is 3 carbon atom in a carbon chain, that we may call that pro. If 4, then but. If 5, then pent. If 6, then hex. Okay, so if 7, then hept. If 8, then oct. You see, if in a carbon chain there is one carbon atom, that is called meth. For 2 carbon atom, eth. For 3, prop. For 4, but. For 5, pent. For 6, hex. For 7, hept. For 8, oct. Then for 9, non. For 8, for 9, non, and for 10, dec. Like this it will go on. Okay, so the general formula of alkane is this one. N represents the number of carbon atom in a carbon chain. If in a carbon chain there is one carbon atom, okay, that means there, if I place 1, it will be C. If I place here 1, 2 into 1, 2 plus 2, 4. That means H become 4. And this is the formula of methane. What? Methane. Okay, because why it is meth for one carbon in a carbon chain, and AN means it indicates the saturated hydrocarbon of alkane. Next, if in a carbon chain there is 2 carbon atom, okay, that thing I can place it here 2. That means C2. Here also I need to place 2. 2 into 2, 4 plus 2, 6. And this is called ethane. What? Ethane. Are you getting my point? So that means in the member of alkane, if you go down, so in everywhere here we can write like that also. 1 carbon will increase and there 2 hydrogen will increase. That means S8. Next member will be C4, S10. or we can say like that also. If carbon is 4, the double of carbon is what? 8, and you add 2. The hydrogen will become 10. And this is called what? This is called propane. This is butane, and that thing will be the pentane. Okay. Then C6 is 14 will be the hexane. Okay. C7, then 8, 16 will be the heptane. Okay. And C8 is, 18 will be your octane. Okay. So like that we can derive the formulas of alkane. Okay. Now let draw the structure of methane. Okay. Methane, ethane, and all this. You see, methane formula is CH4. Okay, we draw the structure of this. So centrally there is one carbon, and with this one carbon, 4 bond will be there, and there will be attached with hydrogen and carbon bond. Okay, this is the structure of what? Methane. So you can draw it in the form of electronic dot structure also. That means for one bond, already I have mentioned in my earlier video, for one bond, how many electron pair is involved? 2. So let me put here 2, and let me write here hydrogen. For one bond, 2 hydrogen. Let me rub this arrow mark. So for this one bond, 2 electron, then there will be hydrogen. For this one bond, 2 electron, there will be hydrogen. Okay. Now what need to do? I will circle the hydrogen. It indicates that hydrogen and balance is satisfied. In the outer shell, there is 2 electron. Now this is for carbon. Okay, where carbon is also satisfied. Is the EDS. Is the what? EDS of methane. Now let's check it for the what? Ethane formula. C2 is C. Carbon 2, make it double. 4, then plus 2, 6. That means is 6. This is the formula of what? Ethane. And earlier it was methane. So carbon, how many carbon is there? 2. You just place like that, 2 carbon. Hydrogen is what? 6. Here you can place 1. Here one bond, hydrogen. Here one bond, hydrogen, hydrogen, hydrogen. As you can see, in this is the structure of ethane, where 2 carbon is there, and surrounding there 6 hydrogen is there. And in the same way, you can draw the what? Electronic dot structure of ethane. See, already I have mentioned for one, in between carbon and carbon, one bond. Okay, for one bond it involves 2 electron. Again, for this one bond, 2 electron is there. And let me write here hydrogen. Here for one bond, 2 electron, hydrogen. One bond, 2 electron, hydrogen. Here also one bond, 2 electron, hydrogen. One bond, 2 electron, hydrogen. One bond, 2 electron, hydrogen. You just, first of all, you need to fulfill the duplet of the hydrogens. And actually it is already fulfilled. Just this circle indicates that what? Hydrogen, in their outer shell, there is 2 electron. Actually it should not be touched. Okay, the circle, it should not be touched with this electron. Now hydrogen is clear. Now let's check for the carbon. See, 1 2 3 4 5 6 7 8. Yes, under the big circle there is 8 electron. That means carbon is also fulfill its octet. Okay, here also 1 2 3 4 5 6 7 8. Verse. This is the structure of what? Ethane. So like that you can check for rest of the member. So this is your homework. You check for what? Propane, then butane, then pentane, then hexane, heptane, up to octane. Okay, up to octane you just draw in this way electronic dot structures. Okay, now let me rub this. Okay, so alkane we have completed. Now next we have what? Alkene. What? Alkene. ALKENE. Actually it is unsaturated hydrocarbon. Okay, which is formed at least by what? Double covalent bond. It is double covalent bond. The general formula of alkene is what? CnH what? Twice N. This is the general formula of alkene. Okay. So N in the same way in case of alkane, okay, the N represents means what? Number of carbon atom in a carbon chain. So here, so if I place 1, okay, it will be C. If I place here 1, 2 into 1, 2 H2. Now you see, you try to draw the what? If in a carbon chain there will be one carbon, it will be meth. I mean methane, METHE, and it will be methane. But if you, wants to draw the structure of this, you see what to do. Where you will give this two double bond. Does it is possible? No. That means in nature your methane does not exist. In nature your methane does not exist. Okay. So now what to do? We have to check for the next member of the alkene. Okay, next member means second with a second, second carbon atoms. Okay, in a carbon chain, if there will be two carbon atom, okay, the general formula already you know that Cn is twice N. You just place here 2, that means C2. If you place here 2, that means 22 4 H4. This is the formula of what? Your ethene. Why it is eth? Because in a carbon chain there is two carbon. For two carbon we called it eth. And since it is alkene, ENE, that is why ethene. Okay. Next will be what? Propene. Propene. The formula will be in propene means 3 carbon. Just you make it double. Carbon here 3, you just make it double. If you double, that means 6. So hydrogen will be here 6. Okay. If you check it with this formula, then also it will match. You see, here you put 3, 3. Okay, here you put 3, 3 to 6. So C3, 8, 6. Okay. Next member will be what? Your butene. Okay. Next member will be what? Butene. So C4, it just hydrogen will be the double of the carbon. That means H8. Now you will draw the structure of ethene. Carbon is what? How many number of carbon is there? 2. Just give here 2 carbon like this. Okay. See, in between carbon and carbon, there should be a double bond like this. Now, surrounding this carbon, already 2 bond is there and more 2 bond I can form. So, already I have what? 4 hydrogen. So, how many covalent bond I can form? 2. Here I can place 1 hydrogen. Here I can place 1 bond and I can place 1 hydrogen. Here also 1 hydrogen. Here also 1 hydrogen. Now, you see the tetravalency of this carbon is satisfied. Surrounding this carbon, there you will get 4 bond. 1, 2, 3, 4. And with this carbon also 1, 2, 3, 4. And hydrogen is already satisfied. This is the structure of ethene. Okay. Now, let me draw for propene. Pro means how many carbon in a carbon chain? 3 carbon. So, just you give 3 carbon in this way. Now, see, I cannot put double bond in everywhere between the carbon atoms. At least in one place I have to place the double bond. Here I have to give single bond. Okay. Now hydrogen, total number of hydrogen in case of propane is 6. See, with this carbon already 2 bond is there. And how many covalent bond I can form? 2. Because tetravalency carbon they can form 4 covalent bond. So let me put here 1 hydrogen carbon bond. Here let me put here 1 hydrogen and bond. And with this carbon, see, surrounding this you check. See, 1, 2, 3. Already 3 bond is there. Only 1 bond I can make. 1 covalent bond I can make. Okay. here I will put one hydrogen. So many students, what they are doing, they put here also one hydrogen, which is totally wrong, because I mean carbon, this show always what tetravalency. Okay, so with this carbon, how many hydrogen I can place? 3. Now this is the structure of what your topic. Okay, that means in a carbon chain, in between carbon and carbon, you can place only one, that is called double bond. Let me draw for the butene. Okay, let me draw for the butene. Butene. C4, it become hydrogen become double 8. Okay, here you see carbon, there is how many carbon? 4 carbon is there. 1, 2, 3, 4. Now what I have said, at least in one position between carbon and carbon, I can give hydrogen, I can give double bond. Okay, you can give here also, you can give here, you can give. Okay, let me put here, let me put double bond. If I put here a double bond, in rest of the others between carbon and carbon, only I can place single bond. Now you check, total number of hydrogen is what? 8. Okay, now with this carbon, how many bond is there? 1. And how many more bond they can form? 3. So 1, 2, 3. Put it here hydrogen, put it here hydrogen. Now you check with this carbon, surrounding this you need to say total here bond is 1, 2, 3. Then only one bond I can add. Okay, so one bond I am adding here and I am putting here hydrogen. With this carbon also surrounding this, you see there is 3 bond. Okay, so only one bond I can add. Okay, with this carbon, one bond is there only, again I can add 3 bond. So 1 bond, 2 bond and 3 bond. Now you see total number of hydrogen you count. 1, 2, 3, 4, 5, 6, 7, 8. Yes, C8. Okay, and carbon 4 already is for 1, 2, 3, 4. This is the structure of what? Butene. Now let me show you the electron dot structure of, that is ethene. See, carbon and carbon. You know there is what? Double bond. Okay, so for one bond, 2 electron you just give. For one bond, you just give 2 electron. Hydrogen is what? 4. Okay, that means here I can put one hydrogen here, and with this carbon here again one, here one. That means here you give like this. Okay, hydrogen, hydrogen. I will circle the hydrogen first. Okay, then after I will circle the carbon. See, 4, 6, 8. Here also 4, 6, 8. Under the big circle, you see, in case of carbon, there should be 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that means their tetravalence is satisfied. Here also 1, 2, 3, 4, 5, 6, 7, 8. Okay, am I clear to you? Okay. Again, let me draw for butene. For what? Butene. B-U-T-E-N-E. Butene. See, butene means what? 4 carbon. That means C4. Okay, C4 is 8. C4 is 8. Okay, so carbon, how many carbon is there? 4 carbon is there, like this. 4 carbon is there, at least somewhere there will be a double bond. Okay, let me put here double bond, like that. Let me put here double bond. There will be the hydrogen. So for one bond, 2 pair of electron. For one bond, 2 pair of electron. For one bond, 2 pair of electrons. 2 pair, 2 pair, 2 pair. Okay, there will be 2 pairs. You need to now circle the hydrogen. You need to circle hydrogen. Okay, like that. You just circle hydrogen first, then carbon you see 1 2 3 4 5 6 7. Actually it should not be touched here. I think it is touched. So when you draw, okay, one circle it should not be touched with the another circle in this position. So for this carbon you see 1 2 1 2 3 4 and this 4. This carbon is also satisfied. For this carbon you see 1 2 3 4 5 6 7 8. For this carbon 1 2 3 4 5 6 7 8. All the carbon their octet is satisfied. Like that, rest of the other member of alkene you draw the electronic dot structure. This is your homework. Okay, now let's check for the alkyne. What I'm saying, alkyne, alkynes. Okay, formula Cn is twice n minus 2. So first member of the alkyne also doesn't exist, because if you put it here 1, if you put it here 1, 2 into 1 2, 2 minus 2 0, and which is not possible. That means methane in nature it doesn't exist. Okay, so we have to go for the second carbon. So second carbon, if you just place here 2, C2 is will be 2 to the 4, 4 minus 2, 2. This is the formula of ethine. Okay, now check for the propine. 3. Propine means 3 carbon. You just place here 3 and represents the what? Number of carbon atom. Place here 3. 3 to the 6 minus 2 is 4. This is the what? Propine. Next, butane. What? Butane. Butane means what? 4 carbon. How many carbon? 4 carbon. C4. You need to give what? Here C4. Okay. So here also give 4. 4 to the 8. 8 minus 2. 8 6. This is the structure of what? Butane. Okay. If I draw the structure, you see 2 carbon is there. Here you just place it. But this we are talking about alkyne, there will be a triple covalent bond. So here it is triple covalent bond. So here I can put this triple covalent bond. 2 hydrogen is there. So hardly I can make one more bond here. Again I can make one more bond here. This is the structure of ethine. This is the structure of ethine. Okay. If you draw the EDS, electronic dot structure of this ethine, see, for already in the same way, for one bond 2 electron, for this one bond 2 electron, for this one bond 2 electron, for this one bond 2 electron and hydrogen, for this one bond 2 electron, and this is the hydrogen. In the same way, you just satisfy the hydrogen, you just satisfy this, hydrogen. Now you need to satisfy the carbon. Okay, in the big circle, there is 8 electron. I need to satisfy this carbon also. This is the EDS, electronic dot structure of what? Ethine. Am I clear to you? Okay, let me rub it. Now I will show you one more electronic dot structure of propine. What? Py and propine means what? 3 carbons. C 3. Okay, then is what? 4. This is the formula of propine. Okay, so here carbon is what? 3. So 1 2 3. So now what I have said, as before, in as like as alkene, at least in one place I can put the triple bond. If you put here, you can put, if you put between these 2 carbon, you can put, no issue. Okay, so let me put it here. Okay, now with this carbon already 3 bond is there. Okay, one more bond I can add here. One bond I am adding, and I am putting here one hydrogen. Out of that 4 hydrogen, 1 hydrogen I have put it. Okay, there will be one single bond between this carbon. You see, with this carbon I cannot add one more bond because already it is fulfilled. See, 1 2 3 4 surrounding this carbon, you have to see 4 bond is there. I cannot add more bond here itself. Okay, now 3 hydrogen is left. See, here I can place what? 3 hydrogen. Are you getting my point? Yes. See, 1, 2, 3, 4. Hydrogen is 4 and carbon is 3. 1, 2, 3. This is the structure of propane, and you can draw the electronic dot structure easily. So you just remove the bond. 2 electron for this bond, 2 electron for this bond, 2 electron carbon is there on this bond, 2 electron will be there or not. So for this bond 2 electron and write the hydrogen for this bond. Okay, in the same way you just rest of the other member of alkynes you just practice at your home. Okay, so just satisfy the hydrogen, you just circle the hydrogen, you just circle the hydrogen, circle the hydrogen. Now for carbon there will be what? In the circle there should be 8 electrons, see 1 2, and here it is 6 8. And with I mean for this carbon also I need to include 8 electron in their circle, you see 1 2, and here it is 6. With this carbon also I need to include 8 electron, 1 2 3 4 5 6 7 8. Yes, this is the structure of what? EDS, I mean electronic dot structure of propane, and like that you can derive rest of the formulas and you can draw the electronic dot structures. So only just you need to remember the general formula of alkynes, and it is very important for your examination point of view. They will ask what is the general formula of alkane, alkenes and alkynes. Is it clear? Okay, now let me rub it. Now again one point is there, that point is that in exam they will ask you to find out the total number of covalent bond in case of like heptane, like pentane. Okay, first I will check it for the number of alkane. What is the general formula? CnH twice n plus 2. So this is the general formula, this is the what? General formula of alkane. So another formula is there, that is Cn plus 1. By this formula we can what? Find total covalent bond, total number of covalent bond, total number of covalent bond we can find. Say for example, if in exam asks that there are how many covalent bond in case of heptane, so what you will do? Obviously you will draw the carbons. Heptane means what? There is 7, I mean carbon atom is there, you will draw and you will find it and you will count it like that, and it will take time. So just to reduce your time, I mean you can use this formula. Suppose you see heptane, no? So if in exam asks to find the total covalent bond in case of heptane, and you know heptane means what? 7 carbon in a carbon chain, you just put here 7. So 7 threes are what? 21 and plus 2. See 7 into I mean 3 into 7 plus 1. 7 threes are 21 plus 1 22. That means in case of what? Heptane, what? Heptane, total number of covalent bond you will get 22. Okay, okay, let me check whether it is 22 or not. You see heptane, na? 7 carbon, 1 2 3 4 5 6 7. Okay, since it is alkane, so obviously one bond, there is no double bond. See here one bond, here one, like that or not. You see, now you count the total number of bond. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Here one 21 and 22. You count, yes. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22. Yes, total number of bond is what? 22. So see, you need to draw the carbon, you need to count it, so it takes time. So it is better to use this formulas. Okay, you use this formula thrice n plus 1 to find out the total covalent bond in case of alkane. Okay, now in the same way we'll check for alkene. Let me rub. Okay, so in case of alkene the formula is this thrice n. We use only thrice n. This is the alkene, and general formula of alkene is what? 2n H2n. Suppose see, if in exam marks, find the covalent, total covalent bond of what? Butene. What? Butene. B-U-T-E-N-E, butene. Butene means what? 4 carbon. That means formula is what? C4H. What? Double. Because it is alkene, it will be the double. So here see carbon 4. If in the exam asks that find the total covalent bond of butene, just you place here 4. 4 3s are what? 12. So 3 into 4 you will get 12 what? Total covalent bond. If you check you will get the same. Okay, let me check. 4 carbon is there, no? 1 2 3 4. At least in one place I can put double bond because we are talking now about alkane. Okay, so here I need to place single bond. So here one bond I can make, here one, here one, here already 2 bond is there, here one, then here one. Here surrounding this carbon already 3 bond is there, hardly I can place one bond. Here see with this carbon 2 bond is there, hardly I can place here one bond and one bond. See, now you check how many total covalent bond is there. 1 2 3 4 5 6 7 8 9 10 11 12. So it is 12. So it matches. So you use this formula, that is thrice n. Is it clear? Okay. Now let me check for the alkynes. Let me check for the what? Alkynes. What is the general formula of alkynes? Alkynes. And here will be the minus. This is the general formula. Cn is 2n minus 2. This is the general formula of what? So the formula to find out the total covalent bond will be the minus 1. It will be the minus 1. 3n minus 1. Okay. So if in exam if they ask find the total covalent bond in case of butane, what I am saying? Butane. This falls under the alkyne. Okay, but means how many carbon? 4 carbon. C4. Okay, and here if you place 4, 4 2s are what? 8. That means 8 minus 2, 6 hydrogen will be there. This is the formula of what? Butane. Now see, total number of carbon is 4. You just place here 4. 3 into 4 minus 1. 4 3 is 12 minus 1. That is 11. So total covalent bond in case of butane you will get 11. Now check it. Okay, see 1 2 3 4. So at least at one place in a carbon chain I can place triple covalent bond because this is we are talking about the alkyne. 1 2 3 here everywhere single covalent bond. Surrounding this carbon already 3 bond is there, hardly I can place one bond. Okay, surrounding this carbon 4 bond is there already, I cannot add more bond. Here I can add what? 2 bond. Here I can add 2 bond. Now you count total number of bonds. See 1 2 3 4 5 6 7 8 9 10 11. Yes, it is match. It is what? Match. So don't waste time, dear students. Okay, just you use this formula for the alkanes. Okay, for alkane, for alkane, the formula is what? Tricen plus 1. For alkene, the formula is what? Tricen. For alkynes, okay, the formula is tricen minus 1. So you should remember this formula. This formula is for to find out the total number of covalent bond. Is it clear? Okay. So for today, this much. Thank you.